In this video, I will be explaining my code for assignment 4. There are two parts to this assignment. First, creating a LinkedHeap class, and then second, creating a priority queue class using the LinkedHeap structure. For the LinkedHeap class, I have used binary node.py that the professor has provided us to create a binary tree for the heap structure. And for the heap structure, I am following the PowerPoint that the professor provided. The heap structure uses LinkedHeap. So let's take a look at the LinkedHeap class. So first, as you can see, my file structure, I have all the files necessary here for the assignment, the binary node, LinkedHeap. This is the code that I'll be explaining. And LinkedHeap tester, I use the tester to make sure that all of my methods in LinkedHeap class are working as the way it should be. And then I have also created a class called priority queue and the priority queue.py for all the priority queue required methods. And then I also have the priority queue.tester.py to test if all the methods in my priority queue works properly. So let's take a look at the LinkedHeap class. So first I import the binary node so this will be used to insert the key value in the nodes, and this will be used to create the nodes for the binary tree. The LinkedHeap class represents a binary heap tree data structure, specifically a mean heap. It stores key value pairs where the key is used to maintain the heap property, also known as mean heap order. It contains an initialization method, here the init method, which creates an empty heap with a root node set to none, and then initial size of 0. Then I have the getSize method helper method that returns the number of elements, the number of nodes currently stored in the heap, and this size will be used in the priority queue as well. Then I have the insert method here. This insert method allows adding a new key value pair to the heap. The insert operation follows the principles of a binary tree insertion to keep the tree complete, and then restores the mean heap property through the unheap bubbling. So as you can see here, we insert the node, and then we also, this is pretty important, we also have the unheap bubble. We call the unheap bubble method that I've created here to make sure that the node is being swapped if the current node is less than if the parent is greater than the current node. So I'll explain deeper later. So next let's take a look at the unheap bubble. So I'll explain this now. So the unheap bubble method is a helper method for restoring the mean heap property after an insertion. It swaps element between a node and its parent while the current node's key is smaller than its parent key, moving the smaller element up the tree. Then I have also created the delete method. The delete method removes and returns the key value pair with the minimum key from the heap. It swaps the data between the root node and the rightmost node on the lowest level, mostly recent added leaf node, then removes the last node and restores the mean heap property through down heap bubbling. So I have I call the down heap bubbling to restore the heap through the down heap bubbling, and then here then I have the down heap bubble method, which is a helper method for restoring the mean heap. The down heap bubble method is a helper method for restoring the mean heap property after a deletion. It swaps element between a node and its smallest child while the current node key is larger than its smallest child's key, moving the smaller element down the tree. Then I have the print method. Here, this print method prints the element's key value of the binary tree heap in ascending order using an in-order traversal. It calls the in-order traversal method, which is a recursive helper function for in-order traversal. Then I have the peek method. The peek method returns the minimum key value pair from the heap without removing it. If the heap is empty, then it returns none. It accesses the root node to get the minimum element. So so as you can see, I have created, this is not required, but I have created, I've tested it myself. I've created a test for myself when coding this. But I also use the LinkedHeap tester.py that the professor has provided to make sure that the code is running properly. Next, I'm going to explain my priority queue class here. So first, I import the methods from LinkedHeap. The priority queue class represents a priority queue data structure backed by a mean heap that I've created called LinkedHeap. It allows adding key value pairs to the priority queue, removing the pair with the minimum key, peeking at the minimum pair without removing it, and checking if the priority queue is empty. In the priority queue, I have a constructor called init, which initializes a new priority queue instance by creating a LinkedHeap instance, which serves as the underlying data structure for storing the key value pairs. Then I have the add method, which adds the new key value pair to the priority queue by inserting into the linked heap. It calls the insert method of the linked heap class to perform the insertion and ensuring that the mean heap property is maintained. I have the remove method here. The remove method removes and returns the key value pair with the minimum key from the priority queue. It first checks if the priority queue is empty using the isEmpty method. If the priority queue is not empty, then it calls the delete method of the linked heap class to remove the minimum element. I also have the min function here. The min function returns the key value pair with the minimum key from the priority queue without removing it. It calls the peek method of the linked heap class to retrieve the minimum element. Then I have the isEmpty method that checks if the priority queue is empty by verifying if the underlying linked heap size is 0. It returns true if the priority queue is empty and false otherwise. Then I have the length method. The length method returns the number of elements, key value pairs in the priority queue using the linked heap size. It calls the getSize method of the linked heap class to get the size of the linked heap. And then as you can see, I have the main method. This is not required, but this was just for me to test. Actually, I think it was required. It required for me to add all these numbers, specific numbers, and then make sure that make sure that the methods are working properly. So here, in the example usage section, a priority queue instance is created and several key value pairs are added to the priority queue using add method. The size of the priority queue is printed using the length method, which calls the length method of the priority queue class before and after performing a removal operations. The priority queue's elements are printed using the while loop that repeatedly calls the remove method until the priority queue becomes empty. This demonstrates the mean heap property as elements are removed in ascending order of their keys. The final size of the priority queue is printed again to show all the elements have been removed from the queue. So I'm going to use the tester in this case. For example, I run the tester for priority queue, and as you can see, it passes all the test cases. Same goes for the linked heap method.